want to determine how the leading coefficient affects the graph of an absolute value function. And here's what we need to know. We have a leading coefficient. We're going to call it A. And if A is between -1 and 1, then the graph itself is shrunk vertically. So the graph becomes smaller, shorter. That makes the graph appear wider, right? If I have this or I have this, is the second parabola shorter or wider? Well, it's both. Okay. If I have that A is equal to 1, that's just the original function, right? If A is equal to -1, the graph is reflected, let's say that, vertically. Remember, values outside the grouping affect the graph vertically. And if A is greater than 1 or A is less than -1, then the graph is stretched. So for part A here, I'm asked whether each function opens upward or downward. Absolute value normally opens upward, and here we have a negative coefficient. So this one is going to open downward. Again, a negative coefficient, this one opens downward. Positive coefficient, this one opens upward. Negative coefficient, this one opens downward. We're asked to choose the function with the narrowest graph. The narrowest graph is the one that is stretched the most. Now, this is not stretched at all, the last one. This is half as tall, or in other words, twice as wide. This is 2/3 as tall, or in other words, 3/2 as wide. And this one is twice as tall, or in other words, half as wide. So the narrowest graph is this one that's only half as wide, or twice as tall. The function with the widest graph is the one that is shortest, and that is 1/2.